am here with you today. Today also I am doing enlargement with different centers and different scale factors. And what would be the effect of center of enlargement on geometrical shapes? So that is the objective of today's presentation. I hope you will enjoy it. Okay, dear friends, let us take this. This is an example of an enlargement with the scale factor 2. I am taking a scale factor as 2 and the center of enlargement is O over here. One important thing we have to understand in this one is, here the center of enlargement and the vertex of that object figure and the corresponding vertex of that object figure, they lie in the same line. So if I write this as, let me use black pen. If I write this as A and this becomes A dash, O, A and A dash lie on the same line. If this is B, O, B and B dash lie on the same line. And if this is C, O, C and C dash, they lie on the same line. So that is the basic property of enlargement. When the geometrical shape is enlarged by a scale factor more than 1, here scale factor more than 1, what does that mean? Scale factor K is greater than 1, then what is the effect? The effect is the object is enlarged. So object is enlarged, and another is object and image both lie to the same side. They are to this side, this side, you can say same side of the center of enlargement. And in enlargement, when object is enlarged, the object is nearer to the center of enlargement. Object nearer to the center of enlargement. This is nearer to the center of, this object is nearer to the center of enlargement and enlarged object is far away from that. And are to the same side. I have said both lie on the same side, it is like that. So these are the basic properties of enlargement when we enlarge something with positive scale factor at the given center. And about the area relation we have already discussed in our previous video, that's why I am not doing that one. And let us say again the scale factor is greater than center of enlargement, but the center of enlargement is not the origin, it is somewhere at the center of gravity of the object figure. This red one is object figure and this one is the center of enlargement. Here too the object point and image point, object image, object image, object image, like that, and they lie in the same line, and that line passes through the center of enlargement. So I have told in my introduction that center of enlargement, those points which lie in the same line, help us to determine the center of enlargement. What do we do? Through this corresponding point we draw the line, they intersect at this point, and that is the point of enlargement. It is like that. So when the center is somewhere here, the object and image look like this. And we have another case here. The center of enlargement is over here and object figure is red. Again, this is nearer to the center and lie to the same side of center of enlargement, and object is enlarged. So that way this property what are listed over here is also true in this case. Wherever is the center, therefore the conclusion is what? Conclusion, so we have two conclusions here. So one is, number one, center of enlargement fixes the position of the object and its image. Here we have been using the same scale factor 2. In all cases scale factor is 2, but they are in different position. Therefore that center of enlargement determines the position of the object and the image, but the area is the same, their shape is the same. So that is what we have to understand. And the next thing is, what does the scale factor do? Scale factor just helps to determine the size of the enlarged figure. For this, what is the rule with us? The rule with us is that the object area is multiplied by the square of the scale factor. We have done graphical representation and discussed a lot about this in previous presentation. These are the two generalizations. Now we have another generalization to be made. Here too the same thing. Center of enlargement is over here. Object figure has the area 1 and it has the area 4. It is like that. The position is gone here. That's why scale factor multiplies the area, center determines the position. Same scale factor but in different position, objects are enlarged this way. Okay, so that was the first generalization to be made. And next one is what happens with different scale factor. For example, this is our object figure. This object figure when enlarged with scale factor 2 at the center O, so that from O these corresponding vertices lie on the same line. It is the principle. And now it is made bigger. And object and image are in such a position that they are to the same side of the center of enlargement, and image figure is far away than the object figure from the center of enlargement. And when the scale factor is smaller, here I have taken scale factor as half. And what has happened here? When the scale factor is half, then the image is reduced. With scale factor less than 1, the image is reduced. The reduction is also taken as enlargement. This is inverse property. So here this is reduced and the image is nearer to the center of enlargement. Bigger scale factor away from the center of enlargement, smaller scale factor, fractional scale factor nearer to the center of enlargement. And when you make smaller and smaller scale factor like 1 by 2, 1 by 3, 1 by 4, 1 by 5 like that, and 1 by 100 or something like that, very near to 0, then the object comes over here at the center. And then with negative scale factor, when it gets negative, the object and image go to the opposite side of center of enlargement. Scale factor -1, this is enlarged by scale factor -half. So here too, when the scale factor is fractional, the image is nearer to the center of enlargement. Bigger, it is away from the center of enlargement. That is why, so about from this one, another conclusion to be made today is when k is greater than 0 and k is fractional, greater than 0 and k is less than 1, at that time the object is reduced. And is nearer to the center of enlargement. center of enlargement. And when k is less than 0, means negative, the object enlarges to the opposite side of center of enlargement. Okay, dear friends, these are the conclusion made on the basis of this different kind of practical task we have done, and student can be engaged not only with the square, with rectangles, with different kind of quadrilaterals or other geometrical shapes, and they may go with some reference point for irregular shape also, because irregular shape also can be enlarged with the same basic principle. That is it. Thank you, my dear friends. Thank you, dear friends, watching my video in my YouTube channel Math Art Studio. Keep watching it. Every day, every moment, you will have very new experience and ideas in teaching mathematics. Keep watching and do not forget to subscribe us.